I'm happy to have you on the podcast again.
Thank you very much for the second invitation.
Can you introduce yourself to the audience?
My name is Czako Zoltan. I'm a full stack developer now. I'm also working on some AI related projects. I'm using mainly Python for this.
That's great. And you have 2 years of experience working with AI, right?
Yes, that is my experience with AI.
Now, let's talk a bit about neural networks. I'm going to describe it quickly. So a neural network, it can be grouped in 3 layers. These layers have input layers, hidden layers, and output layers. As you know, the input layer will receive the input data and pass it to a hidden layer. And then that hidden layer will perform some mathematical computations on input. Then the output layer return an output data, which is a prediction.
Exactly. It's prediction, it's a classification. Yes, it depends on the problem you want to solve.
And a challenge in creating such a neural network is always deciding the number of hidden layers and the number of neurons for each layers, right?
Yes, this is a big challenge because it affects the results of your model, the accuracy, precision, recall, and things like that. Yes, it's a challenge, but Google created a new deep neural network, AutoML or NasNet. That is the name of this network, which basically tries to automatically set up neural network architecture based on your dataset. This is a really useful deep learning neural network architecture.
It's called NasNet, NasH.net, right?
Yes.
That's interesting. So it will create the neural network based on the data which you provide to Google.
The accuracy of this neural network is already higher than handmade neural network, so it has better results than any other state-of-art neural networks. So it's working really well because it's trying to create automatically an architecture. The training time will be longer, but if you need high precision, accuracy, and things like that, then it is recommended to use NasNet.
And as you said, there are various types of neural networks. Some are simple, such as perceptron, which are just input cells and output cells. There are some that are complex, such as deep convolutional network, which has input cells, kernel, pool, hidden cells, and even an output cell.
Yes. The convolutional neural network is much complicated than a simple neural network, but it has multiple operations, as I said, convolution, pooling, and things like that. But even in convolutional neural networks, there are different architectures in convolutional neural networks because you can use simple neural networks like VGG, which isn't that deep. But there are very deep neural networks like GoogleNet and ResNet and things like that. So even in this domain, the CNN, convolutional neural network, there are lots of different architectures which are more or less complex.
To describe also what CNN is, a convolutional neural network, its main use is for computer vision. It is to allow the computer to see objects and to describe what are in those objects, right?
Convolutional neural networks are used for object detection, so mainly image processing stuff, object detection, recognition, image segmentation, but also this kind of neural networks can be used for recommendation systems or sentiment analysis, not just for image processing, but yes, its main use case is image processing because convolutional neural networks has the best results in object detection. So yeah, it's mainly used for this one, and every company who are researching or trying to create self-driving cars, they are also using convolutional neural networks, and there are a lot of ongoing research in this area.
That's interesting. Now, coming to the architecture of a CNN, here it can be broken even in 3 layers, which is the width, the height, and the depth of the image. And then the final output is reduced to a single vector, which is for the probability score.
Yeah, exactly, because as an output you want to know the object which was detected, the class of the object which was detected. So if it's a car, it's a person, it's a cat, it's a dog. Yeah, and this is why on the last layer you have a list of probabilities. What is the probability that the object from the image is a car or is a person? Yes, but there are other important operations. So convolutional neural networks are using convolutions to create feature maps. Feature maps are just important attributes from the image. For example, colors or edges or shapes and things like that. And convolution it's an operation which helps us to extract these important features from the image and create a list of feature maps. So yes, this is the depth. The depth it's important because if you have many feature maps, then you can have better accuracy, better precision, and things like that. And after the convolution, there is another important operation, the pooling or subsampling operation, because this operation helps us to create spatial invariance. So even if the object is rotated, or in the picture the object is rotated or scaled, the network will recognize as an object.
Now, just to give an example of a convolution, we can have a zebra, and the hidden layer will recognize its stripes, its 2 ears and 4 legs would be divided into 20 by 20 pixels, and then when the convolution is done, all the information set will be merged to form a better prediction. That's why the more features you have, the better the prediction could be.
Yeah, exactly. As the neural network gets deeper and deeper, the model can understand abstract concept. In the first layer, we have only pixels. Then in the second layer, from the pixels, the model understands the edges and understands the colors. And after that, as you said, if you have multiple layers, then the model will start to learn more abstract attributes, like, as you said, 4 legs and the shape of the zebra. And it is important how deep is your neural network.
Now, we also have deep learning. We were going to talk about that. I'm just going to quickly state some uses of deep learning. So deep learning is used for colorizing black and white images, adding sound to silent movies, automatic translation, object classification, image caption generation. As we know, deep learning is a rebranding of multi-layer neural networks.
Yes, the difference is you have many hidden layers. That is why it's deep. As you have more hidden layers, the model will understand more abstract features. This is why it's important how deep is the network. And now, because we have computational power, we can train extremely deep neural networks. In the past, that is why the neural network wasn't so popular, because even now with the supercomputer, if you want to train a deep learning architecture, for example, if you want to train the ResNet for ImageNet, it's a database of thousands of pictures, which is used for object detection mainly, classification. If you want to train a network from scratch without transfer learning, with the most powerful supercomputer, it will take three weeks, which is a lot. This is why now we have the computing power, and deep learning is more popular. And I think as the hardware will be much faster, as it gets faster, we will have better and better machine learning models. This is the future of the IT-related industries.
I agree. As you said, it is depending on the computing power, and as we know, deep learning is also dependent on GPU, on graphic card performance. There are options now. We have options to either buy a GPU or rent it from the cloud. Companies like AWS, Amazon, which have been providing such services at 65 cents per hour. And we also have options like nimblebox.ai, which provides such services. So
yes, 65 cents per hour per training, so only for training. Then for the classification and the prediction you have another pricing, so like 50 cents per 1,000 of classifications. So this is what you said, it's the cost for training your data per hour. Yes, we have lots of services. Amazon has this machine learning service, but also Microsoft, and so in Azure you can find machine learning services, or IBM, IBM Watson. There are a lot of cool services, and on each platform you can have a free account. And if you want to learn to create models and to play around with AI, then you can use these services. You can create a free account and just play with it.
Yeah, so it is more accessible now, and that's why we are seeing so many applications of deep learning.
Exactly, and we have lots of cool libraries that helps us to easily create models, because if we are using Keras or TensorFlow, then we can just import those state-of-art neural networks with already trained weights. We just use, so with transfer learning and fine-tuning, just tune it for your objects, for your classes, and it will work, and it will give you really high accuracy. So this is why it's so easy nowadays, because big companies like Google, Facebook, Microsoft are investing a lot of money in this area. So there are a lot of free libraries that we can use, and you can create a really good model for your business problem.
Absolutely, and you said that big companies like Microsoft, Google, and Facebook are investing into it. We have Google with YouTube, which invested a lot in deep convolutional neural networks. It is being used for the YouTube recommender. It is great for classifying their videos. They are using the user's gender, age, and geography to provide a recommendation for the videos. Right. As you know, they are using knowledge graphs. This is being used to generate their vocabulary for the video listings. And before that, they were referring to Wikidata, which is an open source knowledge graph repository. One can get a list of data from there for training their own neural network. For example, let's say if I go to the Wikidata of YouTube, I would get a structured output in triplets. It would be the entity, Google, property, YouTube, and value, youtube.com. And this can be again using REST requests.
So YouTube has a really good recommendation system. But there can be a problem in each recommendation system, which is the cold start problem. At the beginning, you don't have data about the user. It will recommend you generic stuff. But yeah, using knowledge graphs and if you have a lot of data about the users, then you can, for example, if you have a new user, then you ask the gender of the user, age, preferences, date of birth, and things like that, and then you can just firstly classify the user. You have lots of classes for users, and then recommend a video, a content from that class of users. And this is how you can recommend really good content, even if the user is new in your application. And mainly if YouTube is using knowledge graphs and wiki to have the vocabulary and information about all kind of movies, and they can have a really good recommendation system. As for example, Amazon created a really good recommendation system, and everybody is talking about these kind of recommendation systems. And also Spotify and other big companies are using deep neural networks for this kind of recommendation.
I can't think about many sites who doesn't have that. There are many e-commerce websites which have their own recommendation systems.
Because this is the easiest use case for the machine learning algorithm, because you are just recommending something for the user. If you have a miss recommendation, and if the recommendation is not correct for that user, it's not a big problem. A real challenge is using AI machine learning algorithms in factories, for example, because if there are some problems, then it can have consequences. So we as AI developers, we should think about use cases using some machine learning algorithms in industries for predictive maintenance, for example, or using in the medical field for predictive maintenance for humans. So to predict if in the future there will be some health problems if you continue with this lifestyle, or now we should focus also on the industry and to have something physically tangible. Yeah.
We have Tensorflow.js. Tensorflow.js is allowing TensorFlow algorithms to run on the browser. It is not an exact replica of TensorFlow, but it is a version of it which runs on the browser.
So for machine learning to train, it's recommended to use GPU. And how does this TensorFlow.js? Is it using some things like WebGL and things like that, or?
It is GPU accelerated. Now, also one interesting thing is about TensorFlow is that it is using the GPU of the client. So it is not anything on the server side. I mean, if you have a good GPU on your computer, then it would run better on your computer, and it could happen that it runs slower on another computer which has an older GPU.
Okay, so it's using the GPU, the GPU of the client. Okay.
But there are some advantages of using TensorFlow.js. One is that you can have real-time operations of algorithm. For example, you can use your webcam and do some processing with the data which it gets in real time, similar to what we have with Snapchat, I think.
I never used TensorFlow.js. I have some experience with TensorFlow in Python. It's an interesting idea to have a machine learning browser.
It's open to a new market, I think, because now the people who are not really familiar with Python, they are more on the JavaScript side, can also benefit from TensorFlow with that. And it has a lot of the same features. For example, you can change the number of neurons, the number of activation functions and dataset in the browser. And at the same time, you can also benefit from some other features such as the sensor, which is on your smartphone. You can use the GPS, the microphone, the accelerometer, even the gyroscope and the camera for creating new data models.
Yes, and it's divided in low level and high level APIs or API, or it's just high level. So I mean, in TensorFlow in Python you can work low level with tensors, with data graphs and things like that, and then high level you can import all already created and trained neural networks, and you can use those for classification or for your business problem. TensorFlow.js has also these functionalities, or it's you have to build your model from scratch.
You can import a pre-trained model, for example, MobileNet and even NasNet, or if you already have your model created in Python, you can import that one to your TensorFlow.js. So that's where you benefit from knowing Python and TensorFlow.js as well. If you know both sides, you can use both together.
Yes, it's really nice. So if I'm working in Python, I just have to save my model, and then I can import it in TensorFlow.js and use on the client side. For example, you can train your models in the backend, so where you have a lot of computational power and things like that. And after that, when you have a good model, then you can save those weights and save the model in a file, and then send to your mobile phone, let's say, and have the same precision and accuracy as on the server side. For example, if you are using a cloud service, then every time when you want to classify something or to get a prediction from the model, you will pay for that service. So you will have to pay for each request, little money. So it's not a big deal, but if you have lots of users, then you will have big costs. But if you only train your model in those cloud services and then just download these models and use locally on your mobile phone, you don't have to send requests to the server side, and you can have a cheaper application, a cheaper product.
I think that's what Snapchat and other mobile applications are trying to do, to have a lot of the algorithms run directly from your mobile phone. And now, because we have such good mobile phones such as iPhone with a new AI chip, I think it's having an specialized AI chip for such processings.
Yes, because nowadays the mobile phones has really high processing power, and there's a little difference between my mobile phone and my laptop. So yeah, we can use the processing power of mobile phone for deep learning. Yeah, it's really cool.
We have other options such as transfer learning. This is really good if you want to save some time and perhaps some money as well, because you can take knowledge which has been in, for example, from another model and transfer it to your neural network. Is that right?
Yeah, exactly. I was using this kind of transfer learning that you are describing. Yes, it's really cool, because when you start a project, you don't have so much images, so much labeled data to train the model from scratch, and then you can use pre-trained model. For example, you will use NasNet pre-trained using ImageNet dataset, the ImageNet dataset, which has thousands of images. So it's a generic object detection and object classification. It's a dataset for general object detection, and you can fine-tune your model for your problem. So you can take down the last neurons or the fully connected layer, which is used for classification. You can remove that fully connected layer from the pre-trained model, and then train the fully connected layer on your images, and use this fully connected layer trained on your dataset with the pre-trained model, and it will give you a really good. So it will give you state-of-art accuracy and precision. This is the technique of transfer learning. So you can download a pre-trained model, remove the last part, the fully connected layer, and maybe some other hidden layers from the end of the neural network, and then use your images to train, and then fine-tune the model for your business problem. Yeah, it's really helpful, because you don't have to train your model, I don't know, weeks, because there are lots of images and lots of objects, but you will train it in a day, let's say, for your business problem, and this will be really fast.
That's great. I believe that TensorFlow allows for such features such as transfer learning. Now we were also going to talk about ML.NET, which is machine learning.NET, which is a new open source library for machine learning from Microsoft.
And what is used for machine learning for the backend? Is it using CNTK, because Microsoft has this CNTK backend for machine learning and deep learning, and this can be used also in Keras, for example. Instead of using a TensorFlow backend, you can use the Microsoft CNTK backend, and it's working. So
it can be called an extensible framework because it has support from for CNTK, Code.NET as well, and then of course we call it the Microsoft Cognitive Toolkit, and finally it even supports TensorFlow. So it is very extensible at the moment.
So it's basically a wrapper around these machine learning technologies, and you can choose what kind of backend do you want to use. So TensorFlow or CNTK or whatever you like.
Absolutely, you can.
And you are working in C#.
It is compatible with C# or F# for those who program on F#. It is built for .NET developers mainly though.
You don't have to learn Python or anything else. If you are a .NET developer, then you can create machine learning with your C# knowledge.
Absolutely. It is recommended to be used on .NET 4.7.2 and onwards. So if you've been using an old .NET versions, then you will have to upgrade to a newer version. It is cross-platform. It is able to run on Windows, Linux, and macOS. However, the 32-bit of Windows is not supporting TensorFlow. So if you are using Windows 64-bit, then you can benefit from TensorFlow as well. It is proven. It has been used for Windows Hello, Bing Ads, PowerPoint design ideas. So it is being
so it already has some use cases and really powerful use cases. And does it have a big community? So and documentation and things like that? Because if you are a C# developer, you will have to learn. I think that it will have some specific ML specific subset of C#. So you have to understand and to learn how to use this ML.NET. Does it have a good documentation and community to ask questions and things like that? Because it's really important in this field.
Absolutely, I agree. Actually, my choice of language also depends on how big the community is, so that I can find answers to my bugs.
Exactly.
When researching about ML.NET and also trying it, I found a lot of good websites. For example, you have GitHub itself, which is providing a lot of information for .NET.
Do you have some free projects, open source projects on GitHub, in which you can see some examples of machine learning and machine learning in C# and ML.NET?
Yeah, actually I have a list of which I'm going to tell you now. So we have, for specific machine learning tasks, we have projects. For example, for binary classification, we have a project which is allowing for sentiment analysis as well as spam detection.
Okay, I understand spam detection, because it's or spam or not spam. Yes, it's a binary classification, but the sentiment analysis. Why is this binary classification? Is just sad or happy, or I don't understand.
Yeah, this one is a bit simple. It's just sad or happy, but you can modify it and make it more complex. It is just classifying the elements into two groups, either sad or happy. But we also have other samples. We have the multi-class classification, which is allowing, this is a good one, it is allowing Microsoft to classify issues on GitHub. So whichever issues they get for their sample projects, they can classify in 3 or more classes. For example, they can classify it by importance.
Okay, so this is a really helpful example, because actually when you are using machine learning in production, mainly you will have problems with multi-class classification, not with binary classification. Binary classification is simple, but in the real world you will have multi-class classification, and yeah, this example is really useful. I'm really curious. I will take a look over this example.
Absolutely, these are great for creating your own app. Even you can take those and modify it to make it even better. And then we have also regression. This is something I use a lot. It is for predicting a numerical values, and I will be using this one for price prediction for an application which I'm working on. It is having some algorithms which allows you to predict the future price of a product, to do sales forecast and even demand forecast.
Nice. It's a great idea. I wish you success in your project.
Thanks. Now next we have recommendations. This is something which we've been talking. There's a C# sample for a movie recommender, and there's also I think a couple of YouTube videos which are describing this sample. It is quite simple but very extensible.
It's simple because it's just an example, but you can extend it and you can have really good models even if the example is simple. It depends on you and your training process.
Next we have clustering. This is something important as well. It is grouping a set of objects in the same cluster, in the same group, and this is being used for customer segmentation. There's a sample for that itself, so it can be used in CRM applications. For example, if you already have a CRM application and you want to add some machine learning features to it, then you can take some inspiration and take some ideas from that sample.
Yeah, for big companies, this would be really helpful.
Now we were talking about healthcare also. We have anomaly detection as a sample here. It is used to identify suspicion-raising data, and there's a sample for fraud detection as well as medical problem detection here.
Yes, this is interesting. It's really interesting for me because I'm at the university. I'm working in a research project, and we are researching this, and we are researching this field, anomaly detection, and mainly the medical problems like EKG and things like that, and to predict some health problems before the doctors will see these problems. So yeah, this is really helpful, and it has lots of use cases, and this can be used also in factories and also in, as you said, banks and medical fields. And I think that this part of the AI will be really helpful for the humanity, not only for the business, for recommending some product and buying and making lots of profit, but even for daily usage. And this is why I am working on this anomaly detection. This is a continuous learning process, because in this field, in machine learning and AI, in programming, every day you have to learn to be up to date and to create something new, something useful.
We have deep reinforcement learning, which even works in plant maintenance and robotics. So you can see that AI is really going industrial as well. It is going with IoT, it is going with healthcare.
Yeah.
It is really covering all the fields in some way.
And I am really happy for this, because I think that if we will block on that part, on recommendation systems and things like that, then this is not that important in machine learning. But as you said, in robotics, and if we are using machine learning in industries, then it will have lots of use cases and breakthroughs, and it will change the world, I think.
Absolutely. In fact, in robotics, it is being used for automatically calibrating machines and optimizing the supply chain network. And I was part in a project where we were optimizing electricity usage using artificial intelligence.
Optimizing electricity usage?
Yeah, we were using Sonoff IoT devices. I don't know if you heard the name, Sonoff.
Yes. So the main idea is that you had some connected devices, and based on statistics and usage, so a user style and user lifestyle, you reduced the power consumption in, for example, when the user it's not at home, you don't have to use some electric devices. So this is the use case.
Absolutely, we had sensors and all, but this can also be scaled to a server room. When the server room is already cold, you don't run the fans or the AC for that matter. And this can save a lot of electricity and money as well.
Are you still working on this project, or you finished this one?
It is an ongoing project.
Nice. You have some experience with machine learning and things like that. You have some real projects. Yeah, this is how you can learn this field, trying and creating something. Then you can learn. But so even if you are reading blogs and articles and books, because this is how I started to learn machine learning. I started with research, reading lots of articles, books, and things like that. But without practice, you don't understand exactly what's happening. You can understand the high level, the theoretical part, but it's important to work on real projects to get knowledge on that.
Yeah, applied learning is the best learning.
Yes.
And you can see that it's even in the theory report, it says the same. If you go to the corner of learning, you would find that you can retain the most information when you are applying the theory.
Yeah, exactly. It will become reflex or something like that, and you won't forget. If you create a project and you will have some problems with that project and you will fix those problems, then afterwards you won't forget that what was the solution for that specific problem. I think this is the best way to learn everything, not just machine learning.
It's been really great talking to you, Czako, and I got to learn a lot from you about machine learning and artificial intelligence.
Yes, it was really it was a nice conversation. I also heard about a lot of cool stuff like ML.NET. It's really useful because I'm a .NET developer, and it's a really good idea to have a wrapper around these machine learning concepts using ML.NET and C#. So definitely I will try this one, and I want to learn this one. Thank you very much for this conversation.
And you can find some YouTube videos for ML.NET. There are lots of tutorials online. If you like to be a visual learner, if you would like to have your video running at the same time as your typing code, or if you want to go the other way, you can also use GitHub documentation, and there's a great deal of documentation and samples there. You can go that way as well. So there's a lot of support from the community at this point. Even though it is still new, the current version of ML.NET is 0.8. It is not even 1 at this point, but there's a lot of support and it's evolving really fast.
Nice. Yes, I'm a big fan of Microsoft the .NET. So definitely I will try this one. In the future, if you have questions or mainly related to AI, and if I can help you, then we can have another conversation, or you can call me anytime and just talk about this kind of stuff, because yes, I'm really happy to talk with people, because every time I can learn new stuff. It's useful. It's a constructive way to learn and socialize.
Same here. You are welcome to be on the podcast again. So just let me know, and I will be also contacting you maybe if I have any AI question, which I'm sure I will. And see you, and have a nice weekend.
Have a nice weekend, and talk to you later. Bye.
Bye-bye.